Determine the formula for each sequence. Assume n starts at 1. The first step is to look for a pattern in the sequence. Looking at the sequence 2, 6, 10, 14, 18, 22, and so on, notice there is a pattern. 2 plus 4 is equal to 6. 6 plus 4 is equal to 10. 10 plus 4 is equal to 14. 14 plus 4 equals 18. And 18 plus 4 equals 22. Because we have a pattern of addition, this is an arithmetic sequence. Because the first term is a sub 1, we say a sub 1 equals 2. And again, because the pattern is the terms are increasing by 4 each time, we say the common difference d equals positive 4. But take a look at the notes on the right. We can write the formula for an arithmetic sequence as a sub n equals a sub 1, the first term, plus d, the common difference, times the quantity n minus 1, where the common difference d is equal to a sub n minus a sub n minus 1, which means we can determine the common difference d by selecting any term in the sequence except the first term, and then subtracting the term before it. Going back to our sequence, notice 22 minus 18 is 4, 18 minus 14 is 4, 14 minus 10 is 4, and so on, which is why the common difference is 4. And now we can write the formula for the sequence in the form of a sub n equals a sub 1 plus the common difference d times the quantity n minus 1. Notice the formula is going to be a formula in terms of n. We have a sub n equals the first term of 2 plus the common difference d of 4 times the quantity n minus 1. This is the correct formula. Let's go ahead and simplify it by distributing the 4 and combining like terms. We have a sub n equals 2 plus 4n minus 4. Simplifying, we have a sub n equals 4 minus 2 is negative 2. Let's write a sub n as 4n minus 2. And of course, we can test the formula. To find a sub 1, the first term we substitute 1 for n. 4 times 1 minus 2 is 2. To find a sub 2, we substitute 2 for n. 4 times 2 is 8. 8 minus 2 is 6, and so on. And now let's look at the second sequence. The terms are 2, 6, 18, 54, 162, and so on. Again, looking for a pattern, you may recognize we now have a pattern of multiplication. 2 times 3 is equal to 6. 6 times 3 is equal to 18. 18 times 3 equals 54. 54 times 3 equals 162, and so on. Because we have a pattern of multiplication, we have a geometric sequence. Again, we can say the first term a sub 1 equals 2. And because we're multiplying previous term by 3 to get the next term, we say the common ratio r equals 3. Again, looking at our notes, for a geometric sequence, we can write the formula in the form of a sub n equals a sub 1 times r, the common ratio, raised to the power of n minus 1, where the common ratio can be found using the formula a sub n divided by a sub n minus 1, which indicates we can select any term in the geometric sequence except the first term, and then divide by the previous term to determine the common ratio r. Notice 6 divided by 2 is 3, 18 divided by 6 is 3, 54 divided by 18 is 3, and so on. And now let's work on writing the formula. We have a sub n equals a sub 1 times r to the power of n minus 1. I'm going to write r in parentheses. And now we'll perform our substitutions. We have a sub n equals a sub 1, which is 2, times the common ratio r, which is 3, to the power of n minus 1. And we'll go ahead and leave the formula in this form, but we'll go ahead and make sure it actually works. We know a sub 1 must equal 2. If we substitute 1 for n, we'd have 2 times 3 to the power of 0. 3 to the 0 is 1, 2 times 1 is 2. To find a sub 2, which is 6, we would substitute 2 for n. A sub 2 is equal to 2 times 3 to the power of 2 minus 1, or 3 to the first, which does give us 2 times 3, which is 6. I hope you found this helpful.